We're going to talk today about integer exponents. Now, we've already done things like 3 to the second power. 3 is your base, 2 is your exponent, and 3 to the second means 3 times 3, which is equal to 9. But what does it mean when you have a negative exponent or an exponent of 0? So let's use this table down here on the bottom to kind of see what's going to happen with that and if we can figure out a pattern. If I move down from 5 to the 5th power to 5 to the 4th power, I have undone one of the multiplications by 5. So that means I'm going to divide by 5. If I move down again, I divide by 5 again. Move it down another one, divide by 5, divide by 5. So let's keep this pattern going and see what happens. If I move from 5 to the 1st power to 5 to the 0 power, I'm going to divide by 5, and that's going to give me 5 divided by 5, which is 1. If I move it down again, which now I'm going into the negatives, 1 divided by 5 is 1/5. And if I do that again, I have 1/5 divided by 5, which is the same thing as keep it, change it, flip it, gives me 1/25. Now we're going to use this right here to come up with the answers to our rules. The first one is the zero exponent property, which states very clearly that any non-zero number raised to a 0 exponent is 1. So we just saw that 5 to the 0 power is equal to 1. And -3 in parentheses to the 0 power is equal to 1. And 0.75 to the 0 power is equal to 1. And 1/2 to the 0 power is equal to 1. So any non-negative number raised to a 0 exponent is 1. The negative exponent property says that any non-zero number raised to a negative exponent is equal to 1 divided by that number to the opposite or the positive exponent. There's a little easier way to say that. It's that a negative exponent means to make it the reciprocal of that number. Okay? The reason that they use the word non-zero is because 0 to the 0 power and 0 raised to a negative exponent are both undefined. Remember, when we got 0 to the 0 power, we divided by the base. And that's how we got to the 0. Well, 0 divided by 0 is undefined. And the negative exponent meant reciprocal. So to take the reciprocal of something, you put a 1 on the bottom and flip it over. Well, that would make it 1 divided by 0, which is undefined. So let's go ahead and use some of these things. All right. Here, this says that 1 cup is 2 to the -4th gallons. It's asking us to simplify this. We never leave negative exponents. I put a little hint down here for you guys, and I said, remember that the parentheses around the base number means something. So 2 to the -4th power is equal to 1 over 2 to the 4th, and 2 to the 4th is 16. Okay? Let's do this one. 10 to the -4th power is equal to 1 over 10 to the 4th. Remember, the instruction said 1 divided by that base to the positive exponent, which is going to be 1 over, and that's a 1 with 4 zeros. All right? Here, -2 to the -4th power is going to be 1 over, in parentheses, -2 to the 4th. And -2 to the 4th is positive 16. If that parenthesis was not around that, that would have been a -1/16. Okay? Let's keep going here. If I have -2 to the 5th power, that's going to be 1 over negative 2 to the 5th. You'll notice that the negative's gone on these exponents because it did its job. It made the reciprocal. And this is going to give me 1 over 32. Okay? Here you'll notice that the negative is not inside there. Oops, this is a negative right here. My bad. Okay, and here it's on the outside, so that's going to be the opposite of 1 over 2 to the 5th power. But that, again, is going to give me a negative 1 over 32. So just be careful with those. Okay? All right. So we know that that x to the negative n power is the same as 1 over x to the n, or the reverse of that is true. If you have a base in the denominator with an exponent, you can actually bring it up to the top by putting a negative exponent. But what happens when the negative exponent is down here? It's very simple. You move it. If it's on the top and it has a negative exponent, it goes down to the bottom of the fraction. If it's on the bottom and it has a negative exponent, it comes up to the top. And when it moves, the negative part of the exponent goes away. Okay? We do not leave negative or zero exponents. That's not considered simplify. We have to be written with only positive exponents. Okay? So here's some examples. Now, with this first one, again, you probably want to pause and try to do these yourself first and then check with what I'm doing. But with this first one, this is 7 times w to the negative 4th. It's kind of like having the negative sign out front there. That 7 is not attached directly to the w. So that negative exponent only goes to the w. So in this case, this is going to be 7 over w to the 4th. This is the only part that moves, and it moves down. If I wanted the negative 4 exponent to go to the entire 7w, I would have needed to put the 7w in parentheses. Negative numbers do not move. Negative exponents are what makes things move. So this negative 5 on the top here is absolutely fine. But this k to the negative 2 on the bottom is not. So he's going to move up to the top. When he moves up here, the negative 2 becomes a positive 2, and this would be negative 5k squared. Hopefully this one's going to make it much clearer. First of all, any non-zero number to the 0 power is 1. So a to the 0 power is 1. Okay? This has a negative exponent, so that's going to move down to the bottom and become b squared. This c has a negative exponent, so it's going to move to the top and become c cubed. So what do we have? We have 1c cubed on the top, and we have a b squared d to the 6th on the bottom. That's simplified. Doesn't have any zero exponents, doesn't have any negative exponents. And that's all there is.